Assalamualaikum warahmatullahi ta'ala wabarakatuhu. I'm Albayni Esumagka, and this is the continuation report of Ms. Bayman Amirul, and my topics are all about even and odd function, Wallis formula, and change of limit with change of variable. So now, let's start with even and odd function. At first, even function, a function that remains unchanged when x is replaced by negative x, such as that f of negative x is equal to f of x, is called an even function. This means geometrically that the curve is symmetric with respect to the y-axis. So next is the odd function, a function that changes when x is replaced by negative x, such that f of x is equal to negative f of x, is called an odd function. This means geometrically that the curve is symmetric with respect to the origin. Of even and odd function. These are the theorems on even and odd function. A. If function of x is an even function of x, then the integral of f of x dx is equal to twice the integral of f of x dx with the limit of 0 to a. B. If the function of x is an odd function of x, then the integral of f of x dx is equal to 0 with the limit of negative a to a. So this is the example number 1, and let's evaluate it. The integral of 6y squared minus 5y raised to 4 divided by dy. So since the exponent here is even, which is 2 and 4, then this function is even function. So now let's apply the theorem, which is twice the 2y raised to 3 minus y raised to 5 with the limit of 0 to 1. So next, substitute the upper limit to the function minus to the value with the lower limit, which is 0. And then simplified, then the answer is 0. So this is the example number 2. Then let's evaluate the integral of x dx over the square root of 2 minus x squared with the limit of negative 1 to 1. Then after substituting the x with the negative x, the function becomes negative. Therefore, the function does change. The application of the theorem, therefore, the value of the function is 0. So let's proceed with the Wallis formula, which is integral of sin m x cos n dx is equal to m minus 1, m minus 3 until it reaches 1 or 2 times the n minus 1 and n minus 3 until it reaches to the 1 or 2 with the infinity of m plus n and m plus n minus 2 until it reaches 1 to 2. So this is the example of the Wallis formula. Example 1. Let's evaluate the integral sin 4th x cos 5th x dx with the limit of 0 to pi over 2. Then just based on the Wallis formula, which is m minus 1 is 4 minus 1 is equal to 3 until it reaches to 1. And same as the n minus 1 is 5 minus 1 is equal to 4 until it reaches to 2 or 4. And for the infinity, we use 1 because n is equal to 5 is an odd integer. And in the over, m plus 1 is 4 plus 5 is equal to 9 and until it reaches to 2 or 1. And equal is 8 over 315. Just multiply. So this is the example 2. Let's evaluate the integral of sin 2x cos 6 dx with the limit of 0 to pi over 2. And same as the process, just based on the Wallis formula. And here in the infinity, we use pi over 2 because both m and n are even numbers. So the equal is pi over 256. So now our last topic is all about change of limits with change of variable in the definite integral. Changing the variable by algebraic situation or trigonometric substitution, we either return to the original variable or change the limit to correspond with the change of variable. So this is the example of change of limit with change of variable, which is integral of 1 minus x squared times 5 all over 2 dx with limit of 0 to 1. So notice that the exponent is fraction, so we will multiply it. This is by Walli's formula. So to get this, just based on my previous video regarding this, to get the Walli's formula. So for the limits of the 0 to 1, so when the x is equal to 0, sine theta is equal to x, and theta is equal to arctan sin 0, and theta is equal to 0. So when x is equal to 1, sine theta is equal to 1. Theta is a arc sin 1, and our theta is equal to pi over 2. And that will be all. Thank you very much.